It's Don here from the board. Thanks for coming along and checking out this video. So you might see by the title that today's video involves Vegemite. For those who don't know what Vegemite is a B vitamin yeast extract spread. It's very well known in Australia. There are different variants of it in different countries around the world. For example, Marmite is very similar to Vegemite, and Promite and other things of that nature. Now, the context here though on why I'm looking at Vegemite is because I came across a picture, an image, which was a Twitter feed type of thing, and it said this. So, reasons for always having a jar of Vegemite in your survival kit is it lasts forever. Yep, it's pretty much yeast extract full of salts, so it's not going to go off. Practically nothing else is going to live in it. Easy umami flavoring. It's used, for example, as a beef stock replacement. Adds a lot of flavor. Good source of vitamin B. Yep. Deters drop bears. I don't know about that. Probably not tested. And contains so much salt it can be used to create or repair circuits. And then somebody else has gone and actually tested it on bread with some LEDs and power supply, and supposedly it works. So I thought, would it actually work to repair your keyboard PCB? Maybe, maybe not. Could be a bit of a stretch. Now, before we go any further, this video is 100% not sponsored by Vegemite. But Craft, if you want to, please reach out and we can talk. But I don't really expect that is going to happen. So, why did I go down this path, and what kind of crazy is this? Well, you may have remembered a while ago I tried to make a homemade conductive glue using graphite powder and PVA glue, and it partially worked. It didn't fully 100% work, but some of the actual switches in it worked, some of it didn't, and it proof of concept wise, it went to show that idea is there, but the execution is probably going to let you down. So what I wanted to do with this is I wanted to extend on that. I wanted to take it further and, well, can Vegemite be used as a conductive medium as per that image on your PCB? So what I have here is a PCB. This is one of my rotary macro pads. It's a really simple one. On this side, we've got the actual columns and row assignments actually printed on the PCB, as I like to do, although focus is not really cooperating. So what I want to keep reference here is column 0 is actually at D0, between D1 and D4. And column 0 is this one there, I believe, if I follow the trace around. I think that is where the column will go. I hope, but I can just test that right now with the multimeter, because what I'm going to do is I'm going to end up putting a switch in it. I'm going to put some Vegemite on it, and then we can actually see how that goes. So that's assuming, there we go, a little bit slow on the reading, so there's my resistance value. So on that and on D0, maybe not. Hello? Okay. Right, I'm looking for C6 actually. Column 2. That obviously must be the 0, 1, and 2. So I'm looking for C6 instead. Okay, so and then the row should be row 0, which will be E6. If I go over on this side, and it'll be E6. Okay, so I'm looking for C6 for the column and E6 for the row. Now, I've got a diode here. It's a bit of a dodgy one that you just saw me take out of those ones there that were loose, that I hadn't actually glued in. I'm going to be using a NK cream switch, so just to show that it is functional, I'm just going to press it against there, nothing is happening, and then depress the switch and come on, there we go. And if I lift it up and I press it against the contacts, nothing is happening. Hey, and there we go. A little bit finicky to use with these probes. So what I've got here is an actual jar of Vegemite. We eat it at home. We have it on toast and everything else. You can see it is actually used. And here is a clean spoon so I don't contaminate our Vegemite. So I'm going to take a bit of that. That should be more than plenty for what we're going to do. And I'm going to close that up. So if we just have a look at this, the ingredients in here say yeast extract from yeast grown on barley and wheat, salt, mineral salt, malt extract, color, flavors, niacin, thiamine, riboflavin, and folate. And the sodium amount in this is 3,300 milligrams per 100 grams. So there is a lot of salt going on in this. Can you take that and give that to Mummy, please? Put it in the kitchen so I don't end up contaminating. Alright, we'll just put that on the stove, okay? Make sure it's not near the edge. Thank you. So, I've got Vegemite there. The first thing that I'm going to do here is I'm just going to actually test it for its straight conductivity. And that's not... Okay, so I pressed firmly and it was actually touching the spoon, whereas if I'm just in Vegemite, that does not seem to actually be doing anything. So this experiment might be invalid already. So it's not very appealing looking, is it? But we shall press on nevertheless. Although that said, I'm only on 200, so if I go up to 2,000 kilo, will it actually pump enough? Oh, it did something. There was actually some resistance that was measurable there. Yeah, the contacts aren't touching, but there is a little bit of something that's happening. Okay, so that is, it's plausible. It's plausible, right? For keyboard science, Vegemite is plausible. So I'm just going to turn that off at the moment because it's probably going to eat my batteries, and make sure this is actually cleaned so we don't corrode my probes any more than they will already doing this. Alright, so I'm going to get my diode and I'm going to feed it through this the correct way. So it'll be going through there and there. Push that all the way in. Straighten that out as best I can. Hopefully I'm not going to break the leg off this, because if I do, that'll be a little bit misfortunate. Okay, back in. Oh, diode in the wrong direction. Okay, so the diode is in, and it is in the correct direction to the actual footprint. And then what I'm going to do is I'm just going to flatten that like so, and that way it'll give me a good sort of contact surface. Then I'm going to get my switch and I'm going to insert it into where it should go, just like that. Okay, I'll just make sure that's bent around. So let's just get a spare keycap or something there to hold it in place. Alright, now comes the part where we get some Vegemite and we will liberally add it to the joint. And we will shove it in there. I don't know why I do this, but I hope you're enjoying it.
It's silly.
It's silly? Why is it silly? Okay, so I'm going to make sure that the Vegemite is not going to cross contact the parts that it shouldn't. So there we go. I've filled in that switch well there, and then I'm going to take a bit more of that Vegemite and I'm going to pack it in. Okay, I have to kind of be delicate to make sure I don't dislodge that now. Okay. So that is the mayhem. That is... Alright. So let's go to diode mode. And we will go to E6. Uh-oh, that just fell over, but that's okay. E6, and then... Oh my god! So I'm touching the same row on the others, and you will see there is actually what is okay, so on the diode mode it works. Right, now on the resistance, if I go to C6 and I touch the row side, nothing's happening. On the column side, so on the row side, nothing but column, it reads. Column, it reads. And then on the other side of the switch is pressed in, so the column is working, but it's not registering enough to the actual switch. Okay, so now the further test, like that's just to show that the resistance is actually working there, is from a clean pad to a clean pad with no contact of Vegemite, and the switch is pressed in, and nothing. Okay, so that's really interesting. Actually, let's just go down to the 200 in case I'm using my multimeter wrong. And yeah, so it's not generating anything between the switch, whereas if I do want to end up pressing against the pins, you can see that the pins is actually doing its thing, whereas if I go to the pads, then there's actually not enough conductivity happening there. Now if I go to C6 and to that, there is nothing, whereas if I'm touching it to the actual pads directly, there is. Right, so what this is telling me is that it's plausible, it's definitely plausible that the Vegemite is conductive. But what it's telling me though is that you need a lot of power. You need a lot of power. So the amount of voltage that is actually being passed through the Vegemite, because you can even see it's a little bit flaky when I'm touching it to this pin here, sorry, this pad for the diode, is it is working, but it's working intermittently. And what that is telling me is that for the diagram that they used on the toast with the diodes and the amount of voltage they're putting through it, like it's a 9-volt battery. right? Which is essentially what's driving this multimeter is a 9-volt battery, right? It's the same deal inside. It's enough in the diode mode to drive current through the Vegemite. Is it enough to drive resistance measurement? It's not showing up. What does this mean for actually in use when you plug it in? Well, USB devices like these macro pads are a 5-volt device. So will there actually be enough power in 5 volts to do that? I honestly don't know. So that, there's 0 volts there, and it's not generating voltage, so there's no point in me even doing that. But proof of concept wise, it's plausible. It's plausible that if you, for whatever reason, needed to, in an emergency, and you had Vegemite on hand, and you wanted to slather it onto a joint on your keyboard to bridge it for connectivity, if you had enough power pumping through that joint, it would work. Plausible. Would you want to do it? Probably not. What's going to be the long-term effect of doing that? I honestly don't know. Do I want to repeat this experiment again? No, I don't think so. Is it worth revisiting and having to deal with power? I would say also probably not. I mean, I do have a variable power supply, and I hadn't really thought about, using it to run this experiment and put power through the unit. I mean, I could have with 5 volts, and now I've got Vegemite on my desk. It's not something that I really thought that far ahead, because I thought it'd be a little bit more simpler than that, but obviously that was not the case to be. So there you go. There you have it. There is a PCB completely smeared and smudged with brown, sticky, salty Vegemite, and not anything else. There you go. And at least for the diode, it worked. Can't say much else about the switch part, and you can see that I certainly gave it a good amount for it to try and have some contact with, and now I will try and clean that off and hopefully not corrode those pins. Anyway, if you like this kind of stuff, if you think the crazy keyboard science that I do try and attempt and pull off in this channel is your kind of gig, and you're not yet subscribed or liked this channel, would love it if you hit that subscribe and like button, leave a comment below what else you might want to see me try, and so on and so forth. Any of that is really helpful for me to give me more ideas about what else can we do in our space of keyboards. So thank you very much for coming along and checking out this video, and of course, as usual, until next time, happy clacking.